Everybody, welcome. So I'm Nick Matthews. I'm a solutions architect here at AWS, and today we're going to be talking about making PrivateLink the new normal. So, it's a new way for us to privately connect services, and we think it's going to increase the security and convenience of you accessing different networking services. So, for sort of a bit of history, let's talk about what our endpoints have, looked like historically. So let's get a little bit of background here before we dig into PrivateLink. So, step one is have a VPC, put some applications in it, some subnets, all sort of basic stuff. There are services that live outside of your VPC and sort of the greater AWS ecosystem. Services like SQS, SMS, email services, workflow services, S3, Glacier, etc. We have, I think, over 100 of these now. And not all of these live in your VPC. So what happens whenever you want to connect to something like S3? It's a common one. So by default, what would happen is in one of your subnets, you would have a route table. Inside that route table, you'll have a default route for your local subnet, so 10.1 in this case. You'll also have a default route through your internet gateway. So that means that this instance is in a public subnet, and it's going to have a public IP address associated to it. So we're going to route the traffic that wants to go to S3 to the internet gateway. And from there, it will reach S3, and you can reach your buckets and those kinds of things. For each of your other subnets, so maybe on the bottom here, we've got your private subnets. We don't want to give these things direct access to the internet. So what do we do to get to S3? So inside the route table, we'll have the same default route. In this case, we'll add a default route here to instance B, since we're going to route this as through a NAT instance. Or this could also be a NAT gateway. Either way, we have a route to something in a public subnet, which will forward the traffic for us. That will also have a public IP address. So traffic goes to the NAT instance and gets forwarded over to S3. So this is without using endpoints. This is what sort of happens by default. So you're going to need some instances that have public connectivity to reach S3. You'll have to use security groups to block outside access. So if those public subnets need to block anything, you're using security groups there. And this also has the feeling that you're accessing S3 over the internet. So even though S3 is sitting within the same region that you're accessing it in, and even though it's physically very close to you, you're still having to configure this like it's over the internet, and you also have to then deal with the protections, your internal security concerns, all those kinds of things that you would normally have connecting over the internet because that instance now has internet access. So that's where endpoints come in. So if we take a look at endpoints for S3 for this example, what that looks like is we will no longer need these things. So we will not need public addresses to get to S3 anymore, so we can take those away. We don't need default routes pointing to the internet gateway. We don't need to run this NAT instance anymore, or NAT gateway. And we'll end up becoming simpler. And at this point, we can even get rid of your internet gateway. So now we don't have to worry about all of the internet concerns there. So to make this endpoint work, what we end up adding per subnet is a prefix list. So that basically roughly says that all the S3 addresses go to this endpoint. And we'll do that per subnet. So now all the endpoint traffic is going through our endpoint. We can apply some more security. So there's things like endpoint policy. So here at the endpoint, we can say, hey, this network or these endpoints can only reach to these S3 buckets, or they can only do these actions. So we can actually get even more granular what is allowed to S3 from this endpoint. Similarly, we can also apply a bucket policy in S3 that says that this bucket can only be accessed from this endpoint. So you could say that only these instances can reach my S3 endpoint. So if you make this strict enough, like if you're going to go to the AWS console, you won't be able to reach access into those buckets because it says only instances in this VPC can get there. So we can get pretty granular, and this has been very popular, and we've had S3 endpoints for a number of years now. We added this to Dynamo recently as well. So DynamoDB, if you want to access your database privately, same thing. You would now create a different prefix list for each one of these, and you can now access DynamoDB. So this is great. We've called these sort of gateway endpoints. But with PrivateLink, we've introduced a new model for VPC endpoints. So In this case, let's walk through a PrivateLink example. So in this case, VPC endpoints right now are pointing to S3 and DynamoDB, but let's say we want to provide access to the EC2 API or Kinesis or Service Catalog or EC2 Systems Manager. We've recently added some other services like KMS and SNS, and we can access these now privately, but it works differently. So what does the PrivateLink model look like? So the PrivateLink model looks like this. For all these services, each one of them would get an IP address in our public subnet or private subnet, it's not important. But each one of these now looks like it lives in our VPC. So with PrivateLink, you can get to public services privately from your VPC. Each endpoint would consist of multiple IP addresses in your VPC, so it's going to use your addressing range, so it looks like it just lives in your VPC and lives in your subnets. And you don't have to do anything with your route table, so you can scale it higher, and you won't have any sort of additional networking or rights required, which simplifies that quite a bit. And so what happens is whenever you do an API call to, maybe EC2.EU West 1, that automatically gets rewritten to that endpoint in your VPC. So from your application's perspective, they do a DNS request to do an API call. That API call goes to an IP address in your VPC, and it never goes over an internet gateway or any of those kinds of things. It just lives in your VPC. So if you actually want to configure one of these endpoints for AWS services, it's pretty straightforward. You go into your VPC console, you go to Endpoints, you click on Create Endpoint. From there, you're going to be presented this screen that I've got here. It's going to give you 3 options of how to find that service. So in this case, we're going to find AWS services. There's 2 other sort of models here that we'll get into later, which is finding the service by name, so maybe a service that you've created yourself, or by finding a marketplace service. We'll explain what that means later. So for now, what we're going to concentrate in is all these services that are available for AWS. So this is the list. We've got DynamoDB, EC2, Elastic Load Balancing, Kinesis, KMS, S3, Service Catalog, SNS, and SSM. And each of these has sort of a different type. So we can see that DynamoDB and S3 are gateway type interfaces. And then we have interface endpoints that consist of all the rest of these services. So strategically for AWS, it's a lot easier for us to create endpoints for the interface-based endpoints. Because, like I said, the S3 endpoint is 3 or 4 years old now, and it was just Dynamo and S3 that had access for endpoints. Since we released PrivateLink last year, around reInvent timeframe, all these other services, 8 or 9 services now support the interface-based endpoint. So we're hoping to get more and more endpoints out faster and faster through this model. So you'll start to see this be the model that we use to provide private access to our services. And what's cool about this is we're extending this not just for our services, but for other people's services as well. So you can build your own services, or if you access external services from partners, you can do that as well. So what that looks like is you have your VPC, you have your instances in there, and you access some other sort of service. That could be an external SaaS, that could be a business partner that you work with, that could be another VPC that maybe has a slight business connection with you inside your organization, and they've got their own VPC and their own applications, their own security policies. And so what they would do if they want to expose a service to you, or if you want to consume their service, they would have a network load balancer in front of their service, and then that would show up as a VPC endpoint in your VPC. And again, that would show up as interfaces. So it's going to look like that VPC lives, or that service lives in your VPC. And just like the example we showed earlier where you get a DNS name, same thing will happen. You'll get some sort of DNS name for that service. So this one is, the VPC foo service.amazon.com. For those of you that want to get into the mechanics of how this actually works, because the last diagram was a little bit hand-wavy, this is what we're actually talking about. So up top, we're just going to call it our API that we want to share out to multiple VPCs. That's in the 172.16.1/24 space. So that's some address space that we want to operate our service in. At the bottom, we've got the VPC we want to share it to, that's in the 10.1/16 space. So what we'll do is we'll create the network load balancer in front of our service. The network load balancer is going to get a single IP address per availability zone. And that's just one of the features of network load balancer. From here, we're going to put an IP address for that service in each of these subnets of our consumer VPC. So that 10.1 VPC is our consumer. And so they're going to get a random local address. So in this case, 10.1.2.35 and 10.1.1.127. So this API now looks like it lives at 10.1.127 and 10.1.2.35. So it's a local address, some local random address. From here, we would make requests into that IP address, and that would go up through the load balancer to the API server. Now, the API server is going to think that that request actually comes from its load balancer address. So in this case, it would look like the request is coming from 172.16.1.9. So the API service doesn't have to necessarily care that PrivateLink is involved here. If we repeat this, and we want to share this out to multiple VPCs, what it looks like is this. So in this scenario, we have another consumer. They just happen to also use 10.1/16 because it's just a really easy IP address to memorize. And the network load balancer is put IP addresses into two different subnets down here. And it's just randomly gotten different addresses. And these two VPCs may not even know anything about each other. And so what's nice here is that through PrivateLink, you have access and support for overlapping IP address ranges. So whether your developers and testers just habitually use the same address ranges over and over again, or whether maybe you're a provider and your customers are defining those addresses and you have a hard time dictating what addresses people should use, or if you've just sort of gone through sort of mergers and acquisitions, or you've gotten to just a messy combination where you've got lots of environments that share the same address space. Traditionally speaking, it's really hard to share services and monitor and all those types of things when you have duplicate address ranges between VPCs. So this, with PrivateLink, you're able to share services and have APIs that many people can access from overlapping side ranges. And under the hood, basically, the network load balancer from PrivateLink is handling all of the network address translation and address hiding and all that sort of thing. So you don't have to manage that and you don't have to worry about that. And the good thing about this is that it's the same service that AWS uses for our own service. So as you might imagine, there's a lot of customers that want to access the EC2 API privately. And a lot of those customers are using the same default VPCs, and there's thousands of those people. So when you create your own service through this, or you share your own service, it scales out to thousands of VPCs. So it's a really, really scalable feature for us to sort of get to cloud scale in terms of sharing services. Well, part of the other mechanics here is, I've been talking about IP addresses, but very few people actually do API calls to IP addresses. They do IP calls to, DNS names. So the way this actually works is pretty similar to our load balancing. So if you've used an Elastic load balancer service before, you know that whenever you create your ELB or your network load balancer or your application load balancer, you'll get a big DNS name. It's going to be similar here. The difference here is you get multiple DNS names. So the first DNS name that you get it covers the entire VPC with all the availability zones that you've chosen. So you get one fully qualified domain name that covers all your addresses. So in this case, it would cover 10.1.1.127 and 10.1.2.35 on the left. But in case you want to keep all your traffic within the same availability zone, we provide other DNS names that you can use to do that. So you'll get one more DNS name for each of your availability zones. So in this case that I've shown here, each of our VPCs has two subnets. So that means you would get 3 DNS names. If you had more subnets that were in these same 2 availability zones, you would maintain the same address space. So it's only you get another address as you create availability zones. And so to show you what the name looks like here, it's not a particularly pretty name. It's going to be VPC -something, -service, some more hex characters, -region.amazonaws.com. So again, similar to like what an Elastic load balancer name would look like. If we want to make that pretty, there's some things we can do. So we can use what's called an Amazon Route 53 private hosted zone. So in the private hosted zone, you would create a C name. So let's just say this is api.example.com. That's a pretty name we want to use for this. We would create an alias for this name. We would essentially point to the network load balancer name and Route 53. We would then go associate that private hosted zone to each of the VPCs that would need that DNS mapping. And now instances could just go to api.example.com and be able to use this sort of natively without any change to our applications. There's some sort of enhancements to this. So if you list through Marketplace, this happens sort of automatically. So this is sort of the taxonomy of the name here. There's a service ID and the region and then sort of the subdomain. You know, the client, each client will get sort of different VPC endpoints on the left. And if you want a nice sort of pretty name, typically you'll still have the region and subdomain, and you would have the VPC endpoint there on the left. And so it's a little bit easier. It doesn't require the Route 53 step if you go through Marketplace. So speaking of Marketplace, what the model really looks like is, you know, if you're looking to consume some of the SaaS products that are offered on AWS, a subset of those are offered through the Marketplace. And as you're consuming that service, you can go in and say, hey, I'm consuming this service off of Marketplace. I'd really like the endpoint for that service because I know it's on AWS. I don't want to go over the internet to access that. And that can all just sort of work natively. So that's the sort of the third bullet point that I showed earlier when you create your endpoint service. So we're working with the sort of the folks on Marketplace to get more people involved. So that's, you know, like Aqua and StealthWatch Cloud, SIGOP, CA, Dynatrace. Any of those services today, if you get them off Marketplace, you can use their VPC endpoints natively. So let's talk about the use cases of PrivateLink, because I know, you know, I've been a network engineer for a while, and this doesn't really directly map to anything that's on premises. So it's sort of a new model for accessing services. So sometimes people want to talk about, like, okay, how would I use this? What does this actually do? So let's compare it to the world without PrivateLink. What are we doing today? So down at the bottom left, we have a data center coming over Direct Connect to a VPC with some applications in it. That application, you might have multiple VPCs, so you probably have some sort of shared services VPC. You probably use VPC peering to connect that shared services VPC to your current VPC. So what's in that shared services VPC? Well, it could be really anything, but commonly it's, you know, security services, logging and monitoring, maybe your DevOps or CI/CD toolchain, maybe LDAP or Microsoft AD or some sort of authentication tool or single sign-on, those kinds of things. The next place where you're probably connecting to is you're probably using our APIs of some sort. So your instances are probably doing maybe some automation or describe calls or accessing other services like databases and S3 and all those kinds of things, you know, over the internet gateway. And then you may also be accessing partner services. So you may be using logging services or monitoring services or security and intrusion detection services or any of those kinds of things that look like they're on the internet, but they're actually also running on AWS. And from on-premises, you're probably also accessing a number of SaaS services and external services that run, quote unquote, on the internet, but are actually also running on AWS. And we'll talk about how we can also work with that use case with PrivateLink. So with PrivateLink, what does this look like? Let's break it down. All right, so we have our same application, same shared services model. And in this case, instead of doing VPC peering, we'll put a network load balancer in front of our services. And then we will connect that through PrivateLink. And it'll show up as a network interface in our VPC. So now we don't have to connect, we don't have to use peering. We'll get into why that's better. This model is better than peering here in a little bit. From the Amazon and AWS APIs, same thing. You know, we have load balancers in front of all services. You don't have to worry about that part. And so for the services that are available, you can connect over PrivateLink, and that shows up as more network interfaces in your VPC. And for the partner services, we're working with all of our partners, whether marketplace or not marketplace, and we're working on them to expose more and more PrivateLink endpoints every day as well. And you can connect some of those into your VPC through PrivateLink. And from your on-premises network, what you can do is create something like an endpoint VPC. You can say, hey, what services am I using on AWS? And I'd like to put those all in one VPC, connect that over Direct Connect, so I don't have to connect over the internet to get to my resources anymore. I can access partner services, and I can access all of the EC2 APIs privately over Direct Connect. So in this case, what we're really doing is we're removing all the internet access from your VPC and allowing you to connect to all your services privately that live on AWS. So let's dig into these use cases a little bit to figure out which ones make sense and where the benefits are. So in the case that you have a shared services VPC and you're using VPC peering before, what's the advantage of using PrivateLink? One is scale. So customers always have sort of slightly different reasons for using many VPCs. Sometimes it's every time you create a new account, you get a new VPC. So if you'd like to have more accounts, but you don't know how to share services amongst them, or if you want to have more than 100 accounts, that's helpful. Because in this model, you can share services up to more than 100 VPCs. VPC peering locks out at 100 there. As well, if some of these VPCs have overlapping CIDR ranges, you can't use peering for that. So PrivateLink allows you to do that, and that's pretty helpful. As well, if you have a VPC and you peer it with another VPC, there's some, there's 2 or 3 different levels of security controls, but you're effectively sort of binding 2 VPCs together. And if all you wanted to do was access a single service in another VPC, it's pretty inefficient, really, with peering. So in this model, by just putting a network load balancer in front of the service that you want to share with another VPC, you're able to provide much more granular access. And not just that, but since we mentioned that the connections are from the client to the server only, if something in the shared services VPC here gets compromised, it cannot go out and sort of reach out to all of the sort of spoke or application VPCs, the consumers, because you're not allowed to do that with PrivateLink. It's just from the consumer. The consumer's allowed to request stuff, and that's it. So you create a sort of a more secure model for accessing services this way. Does this fit for your service? Well, your service needs to be able to support it behind a network load balancer. So that's a component, which means it needs to support TCP. It needs to be sort of one way. So if your service is reaching out to lots of other services, then PrivateLink, you probably want to use VPC peering for that. Let's look at some other use cases here. So like, why would you want to access our APIs over PrivateLink as opposed to going over the internet? Well, some people just don't like internet access. I work with a lot of customers that, once some part of the VPC can access the internet, there's concerns about data exfiltration, there's concerns about viruses and malware, there's concerns about botnets and all sorts of other things. And that's usually when the security organization has to bring in, a bunch of tooling and monitoring and those kinds of things. But if you have a VPC that has no internet access, that really scopes and reduces the boundaries of what things can go wrong and those kinds of things. So generally that means teams can move faster and don't have to worry so much about that. Plus it actually does increase your security. You just have to make sure that the service that you're working with supports PrivateLink. And so we're rapidly trying to increase that list. So just check that. But today it's the EC2 APIs, load balancing, systems manager, Kinesis, key management systems. The key management system, because it's so security oriented, has been very popular, as well as SNS, so notifications and service catalog. So if you're using those services, I would recommend turning on PrivateLink, and it'll just sort of work automatically once you turn it on with PrivateLink in each one of your subnets. So partner services. So why would you want to access partner services that you're probably already accessing today over PrivateLink? Well, one is maybe there are services that you haven't been able to access or have sort of been wary about accessing over the internet, because again, that's the whole security concern. Here, this means that for parts of your infrastructure, you can basically get rid of your internet connectivity if you can do everything over PrivateLink. As well, this makes sure that the connectivity that you have to the partners is secure and it's one way and all those types of things. And so you can increase the security of your services. You have to make sure that the provider actually offers this service. We recommend you sort of asking your SaaS providers and the people that you're reaching out to from your accounts about this to make sure that we're building out as many partners as possible that have this service. And AWS, if you happen to be a partner and you'd like to offer a PrivateLink service to your customers, let us know or reach out to your AWS people, and we're happy to work with you on that as well. Right now, the PrivateLink does work within the same region, so you'd want to make sure that the partner service that you're wanting to work with is in the region, or there's some other way. We can also use Direct Connect Gateway to access things across region. And then the use case where, like, hey, you're on premises and you want to access some services, some partner services out on AWS. What does that look like? Why would you want to do that? Like I said, it comes down to some customers are wary about, especially if you're sending, let's say you're sending out logs, which may contain sensitive information, or you're doing security analysis, or maybe your data is very secure, but you want to send that data out to some other external source for another reason to share that data, but you don't want to send it over the internet. This is a great way to do that, because these partner services may have multiple people that want to do that with them, and making that scale can be sort of challenging. And so with this is you can create your own endpoint VPC. You can define your own IP addressing scheme. So if you're on the 10. network or the 192 network, it doesn't really matter. You can create one of these, be super flexible with what the addressing looks like. And then you can send it over to the partner services that way. So again, we just need to make sure that the partner services have this enabled. And that, again, that's another place where AWS is willing to help, and we're also working through Marketplace to get more of these endpoints out there. So that's one of the use cases. Let's figure out some of the design alternatives, because not all the designs will look like that, because I've already mentioned a couple of things that PrivateLink isn't suited for today. So what do some of the design alternatives look like? So one is, right now the service is based on Network Load Balancer. So as Network Load Balancer gets more and more features, so will PrivateLink. And that means that any service that you want to expose through PrivateLink needs to somehow be sitting behind a Network Load Balancer. So what does that look like? So I mentioned the region connectivity. If you want to connect to a different service in a different region, how would that work? So what you can do is, if you have a Direct Connect circuit, from there you can create a virtual interface to a Direct Connect gateway. And then a Direct Connect gateway can connect to any VPC in any region. So you can create the PrivateLink endpoint in the remote region, and then use Direct Connect gateway to access the remote region. Right now, inter-region peering doesn't work with this feature. Maybe you may have resources like databases or logging services, or maybe you have your own custom load balancer in front of this service. How does that work with Network Load Balancer? There's other designs that I've seen that may involve like a Network Load Balancer per resource. For instance, if your service expects to see maybe 3 endpoints all the time, if you put a Network Load Balancer in front of that, you may only see 1. So you can create like a Network Load Balancer per service and work like that way sometimes. And same thing, so maybe you need the application load balance for some reason. Maybe you need SSL offload, or maybe you like the path-based routing and layer 7 features of application load balancer. So how would you make that work with PrivateLink? Well, what you can do is you can actually put a network load balancer in front of the application load balancer, and then you can use network load balancer to extend off all of the prefixes. So there's a blog post that just got posted out there a few weeks ago that actually we have some automation and some lambda scripts and all that kind of thing that automatically keep the network load balancer in synchronization with the application load balancer. So if you're interested in doing that, I would check out that blog post there. So what sort of protocol things do we need to worry about with network load balancer and endpoints? So one thing that I mentioned that is worth going back and discussing again is that PrivateLink has the model where the consumer requests things from the provider, and that's a strong one-way relationship. The provider cannot reach out to the consumer. So if you have services like, I don't know, a provisioning service or a vulnerability scanning service where that service needs to reach out to many VPCs, this isn't really the right model for that. You probably want to use VPC peering for that, or maybe even something that uses internet connectivity. As well, the network load balancer doesn't currently have SSL offload. You may imagine that that's a very common customer requirement that we hear. So we're very aware that customers would like SSL offload on network load balancer. So you know our teams are listening to that and listening carefully. But today we don't have that. So you can also use that same blog post that I mentioned earlier, where you put the ALB behind an NLB, and then NLB exposes the endpoint, and then ALB does your SSL offload. So we've tested that. That works. It's not the cleanest solution, but in this case, it can get you on PrivateLink when, if SSL is supported on the NLB at some point, then what you'd be able to do is just remove the ALB and directly route to your targets. But today, we would need to put the ALB in front of that. Another use case I get is customers that would like to do some sort of proxy routing or firewalling or default gateway sort of thing, where they want to use like a transit VPC or a firewall or proxy and share that via PrivateLink. PrivateLink acts as sort of a pure load balancer, so you can't route through a load balancer. So if you actually set a route to the network interface of a load balancer, anything that isn't just the load balancer's listening address and port is going to get dropped. So you can't route through that thing today. So in that case, we have some other network architectures that work. So you may just want to use a transit VPC there. We've got a lot of other sort of content on that, but that's a different use case. So what are some of the good candidate PrivateLink services? So the places where we've seen a lot of customers start to use PrivateLink are things like APIs and microservices, any sort of multi-tenant TCP service. So if you have a lot of users using one service and it operates over TCP, it's pretty easy to put a network load balancer in front of that. Another one is anything that's currently behind a load balancer tends to be a pretty good choice for this, since it already sort of meets the hard requirements. And then more generally speaking, anything that's processing sort of sensitive data. We see this in government, we see this healthcare, financial systems, anyone that has that really cares about their data, this tends to be pretty helpful for them. Or if it's just sensitive environments. If you don't want to share that data, or you have a lot of regulation and control, we see PrivateLink helping out a lot in those types of places. So if we take a look at some of the final thoughts here and try to wrap this up a bit. So if we sort of summarize this whole thing, we've got these interface endpoints now. So this is what your VPC looks like. You've got a couple of instances in your subnet, and now you can get endpoints to 3 different places. You've got endpoints to AWS services. You've got endpoints to your own services. So if you want to share out your own API server or your own DevOps infrastructure or any of those types of things, you can do that. You're probably also reaching out to some external services that happen to also be on AWS, so there are some AWS partner services. And from here, it's a local IP address. So it looks like it's living your entry. You don't do any sort of route table or subnet magic. It can expand multiple availability zones. This thing is also highly scalable, so the network load balancer itself can do tens of gigabits of throughput, and you don't have to worry about pre-warming or those kinds of things. So the network load balancer has the scale that you need. We have DNS names for the availability, and we do health checking on all the services through the load balancer, so you don't have to worry about health checking your services here. That's part of the NLB health check. You can use both the zonal name, which is like per AZ, or you can use the regional name, which would cover all the AZs, depending upon your use case and things like latency or you know, trying to keep traffic within the same AZ for data transfer reasons. You can use security groups with the network load balancer as well. So in this case, you can say, I can only talk to this network load balancer or this PrivateLink endpoint. So that's helpful. And you can access it over Direct Connect as well. So if you want to access your endpoints over Direct Connect, that works today. So what this looks like is you had your applications, and now that it looks like, so now the AWS services live in your VPC, and depending upon which partner services that you're using as well, you can put that in there. You can put your own VPC, so your own services look like that. And so now instead of all these services looking like they're on the internet, they're inside your VPC. So if we, you know, the types of things I'm seeing customers use this for are, you know, logging. Logging is a good one because logging tends to be centralized. It's, you know, sort of one way only from the consumer or the host is actually creating the logs and sending it to the logging server. So that tends out to work pretty well. Monitoring, same thing. So particularly if you have agents and those types of things on your services, and those agents need to register with the service and need to talk to the service and send data, often for security purposes. Those tend to work well in this scenario. Well, I've talked to a number of like Kubernetes customers and customers building like, you know, sort of container ecosystems. They're building on APIs, the sort of service-oriented architecture type of thing. Because all of those have APIs and all of those are generally behind load balancers and sort of horizontally scalable, it's very easy to break those systems out in multiple VPCs now. So I've talked to customers that said, hey, I really wanted to, you know, have this great separation between all my services, but it was too difficult to do the VPC peering and all of that. So with PrivateLink, it makes it easier to break your services out in multiple VPCs if you want to, and then use PrivateLink to sort of share those services between VPCs. So you can actually get stronger isolation between your environments and your microservices by using PrivateLink. And especially if you're a SaaS provider, it's helpful because now you can get your endpoint out to lots of customers. If you're a customer and you use SaaS services, it's great because now you can actually consume those services and not have to go over the internet and not have to worry about your VPC scale as well. So essentially, if we break this down to the benefits, it allows customers to use sort of one set of services. So rather than having to, you know, repeat your service out per VPC or create multiple environments or deal with the VPC peering scaling requirements, PrivateLink allows you to sort of keep one set of services and expose it out to many places at once. You know, it just makes your service look like it's someplace it's not. It's highly reliable and horizontally scalable. The actual mechanics underneath PrivateLink, we talked a little bit at reInvent about this, but it's called a service called AWS Hybrid Plane, and Hybrid Plane is the same functionality that's been sitting underneath services like Elastic File System, underneath our NAT Gateway, underneath Network Load Balancer. And so the actual mechanics and the machinery of this thing, we've been using that for a while. So Hybrid Plane has been in production and has seen just tons and tons of bandwidth. And so the actual, you know, we've done some cool things around the networking magic of making interfaces show up in places that they're not. But the actual hard part of like forwarding the traffic and making sure this stuff's going to be reliable, that's been happening for a long time. And so, you know, yes, this is a new service, but it's not a necessarily brand new thing for us. It also, from an operational perspective, makes things simpler. So I can't tell you how many people I talk to that have overlapping address space for, like I said, some of the merger and acquisitions, and they have a hard time dealing with that. And so it's less management points. So I've talked to people that said, hey, I think we'll create a VPN for every one of my environments, and that's how I'm going to scale this out, or, you know, or I'm going to have some automation around that. This simplifies a lot of that whenever you can share those services out. As well as the security. So I mentioned security quite a bit, but it's worth, you know, wrapping up on it as well. One we hope that we can get enough PrivateLink endpoints out there that you don't need to go to the internet anymore. That's sort of the end goal. Like, if we can get all the endpoints configured and we can get all the services in there, then your VPC at some point doesn't need internet access. Are we there today? Well, it depends on your use case. But the more and more we get into this, more and more that users use PrivateLink, the less reliant we're going to be on internet routing and internet connectivity. For the other security perspective is a lot of customers are hoping that the service they reach out to doesn't reach back out to them. And this actually makes that a lot more strict. And so AWS puts that in as part of the service. And so there's a strict consumer to provider relationship, which increases the security as well. And that's another advantage over VPC peering. So that's the content we have today. Thanks everyone for joining. I hope this was useful for you, and I encourage all of you guys to go out there and go into the console, go to endpoint services, and try out at least one endpoint. And from here, I think we'll just start taking some questions.
All right, great job, Nick. That sounds